Good afternoon or good morning, dear students. Well, on previous practical lesson, we were finding equations of the plane in the space, and today we are working on a straight line in the space, so in 3D, not on the plane, and it will look in a different way a little bit. So I will remind you, first of all, some theory. So this is the canonical equation of a straight line. So x0, y0, and z0, these are coordinates of the point that belongs the straight line. And m, n, and p are coordinates of a direction vector. Direction vector, I will remind you, this is a vector that is parallel to the straight line or belongs it. Then equation of a straight line passing through 2 points. You know it from the school that through 2 points, so only one straight line can pass. So here is the equation that, as you can see, can be transformed to the canonical form. This is the parametric equation of a straight line. So as well, coordinates of the point that belongs the straight line, and coordinates of direction vector, and t is a parameter, is a real number, and as you can see, we can receive a parametric form from the canonical equation. It will be useful in some tasks. Then general equation of a straight line is the following. So you know that the two non-parallel planes are always, so if planes are not parallel, they intersect, and they intersect by the straight line. So this is the general form of the straight line. Of the straight line equation, so two intersecting planes, and other forms can be received from it. Here is equation of a straight line defining a bundle of planes passing through the straight line. So lambda is a real number. So a parameter, we can use values that we need. So here is a straight line parallelism condition. So coordinates of direction vectors are proportional. Then perpendicularity condition. So just vectors, so direction vectors perpendicularity condition, their scalar product is 0. So how to receive cosine of the angle between straight lines? So we divide scalar product by the product of magnitudes of direction vectors. How to receive distance, how to find distance between point m0 of this straight line and point yeah, so point A belongs this straight line L, and point M doesn't belong. So we find cross product of vector m0 and direction vector, and divide its magnitude by magnitude of the direction vector. And here is the condition for lines lying in the same plane. So just as you can see, coplanarity of three vectors basically. So S1, S2 are direction vectors of two planes, and A1, A2 are points that belongs straight lines L1 and L2 respectively. So with checking this so mixed product of these three vectors for 0, we can verify if these two straight lines are in the same plane or if they are skew. And here is the distance between two skew straight lines. So we divide magnitude of mixed product of this vector that mentioned before, and so divided this magnitude by the magnitude of cross product of direction vectors. Maybe any questions about this theory? Okay, if no questions, we will start solving. Mhm. So equations will be in front of you. So the first task is the following. So the straight line is given with the general equations, so two planes, and we need to reduce this equation to the canonical form and find the projections of the straight line L on coordinate planes. So first of all, we need to find the intersection point of so just one intersection point of so that belongs both these planes. How to do it? So if I set uh, I need to assign x, so any of coordinates x, y, or z to 0. So let's assign x, and then we will receive the following system of linear algebraic equations that we already know how to solve. So this system. Okay, let's solve it. So now we are looking for the point that belongs this straight line. Okay, I will do some substitution. So y equals to z minus 3. So just rewrote this equation. And here I will substitute y with this value. Okay, we'll move 1 to the right side. Okay, and now we're looking for z. So 4z minus 6 minus z equals 1. And 3z equals 7. Well, okay, let's check if yeah. So correct. So z equals 7 by 3, and y equals, so okay, so 14 minus 9 by 3, so it's 5 by 3. And finally, we received the point m0 that belongs this straight line. So 0, 5 by 3, and 7 by 3. And now we need to find the direction vector of the straight line. So how to find it? Any ideas? Okay, I will draw a little bit, and maybe it will be more understandable. So I will draw two planes that are intersecting. So this is the plane P1, P2. So we need to find direction vector of this straight line. So this is the normal vector of the plane P1. It is perpendicular to this plane, to P1. And direction vector, so normal vector of the plane P2 is perpendicular to the plane P2. And as we know direction vector of the straight line L, it is so it belongs either belongs the straight line L or parallel to it. So how to receive the direction vector if we know normal vectors of these planes?
Find cross product.
Yeah, correct. So because vector S is perpendicular to both normal vectors. So let's do it. Okay, we'll copy and paste these equations just for easier finding. So just to be these vectors in front of my eyes. So uh, 2 minus 1, 2. 1, 2 minus 1. So minus I plus 2j and plus 4k. Then plus k plus 2j and minus 4i. Let's double check. Yeah, let's double check because minus 1. So now signs are correct. Then 2j plus 2j plus 4k, then plus k plus 2j. Yeah, right. And minus 4i. Okay, now everything is correct. So what we have minus, yeah, we'll continue the next line. So minus 3i plus 4j plus 5k. And let's check. Yeah, minus 3. So plus 3 here. So let's check what can be incorrect here. So I plus 2 plus 4. Plus k plus 2j and minus 4i. Yeah. Just a wrong calculation. So now minus 3i. Yeah, plus 4. What's going on? Yeah, mistake is here. So we calculated everything correctly. So we have the coordinates of the direction vector. So the equation of this straight line is the following. So yeah, just to remind you, coordinates of the point M0. So x by -3 equals y minus 5 by 3 divided by 4 equals z minus 7 by 3 divided by 5. Oh, yeah, divided by 5, yeah. So everything is correct in our case. Okay. By the way, if you find some mistakes in these files, please feel free to let me know about it. Okay, and then how to find out how to find projections of the plane in on coordinate projections of the straight line on coordinate planes. So we just take these parts of the canonical equation. So this is projection of on the x or y coordinate axis. This is projection on x or z coordinate axis. So just the coordinate that is not in use. So by coordinate that is not in use, we can understand the projection on which coordinate axis. We won't waste time with eliminating with eliminating fractions. So this is the final form of projections. Maybe any questions to this task? Okay, if no equation or if no questions, so let's continue. So we have the following task. We need to write down a general equation of a straight line based on intersection of plane P with the following equation and P2 that passes OZ axis and the point K. So let's start. So basically what we need to write down the equation of the straight line, general equation. So we have the first equation for the first plane. So we need to find the equation of the plane 2. So it will have the following form. So a 2x plus a, oh, not a, b2 y plus c2 z plus d2 equals 0. Okay. So then what we have the next. So if we so we know that this plane passes through OZ. So we have point M that has coordinates 0, 0, and Z. So we don't know basically this that coordinate, but with such information we can write the same. So C2 Z plus D2 equals 0. So this is the next. So that's what we have. Then, yeah, by the way, from this we can find out that d2, so we can assign d2 to 0. So the equation of the plane P2 will be simplified. We'll just erase D. And we know that it passes through the point K. So what do we have now? So for A2 plus 3B2 plus 2C2 equals 0. So now we need to find these coefficients. Basically, we can just guess them. So we can choose any coefficient that are good for this equation. So that match the condition. I suggest that next. So let's assign A2, let's assign value 1, 0 for B2, and C2 will equal -2. Can we do it? Yes, we can. And then we will have the following so the following equation of the plane P2. So x minus 2z equals 0. And if we substitute these coordinates of the point k, so 4 minus 4 equals 0. So that's now will be the equation of the straight line L. So the general, if we use this, so if we substitute these equations. So this first one and the second one. Any questions about this task?
No questions.
Okay, so let's continue. So we have a canonical equation of the straight line. And let's write down the parametric form. So how to rewrite it in a parametric form? Basically, we are doing the following. So all these parts of equations are equal to t parameter. So we need to solve these equations with respect to x, y, and z. So let's do it. So x plus 1 by 5 equals t. So now I'm writing it in details. I know that it can be obvious, but for a better understanding, so t z minus 3 by minus 3 equals t. And now we are extracting x, y, and z. So x equals, so we multiply by 5 both parts. So x plus 1 equals 5t, and then x equals 5t minus 1. So just arithmetical transformations. Y equals minus 2t minus 4. Z equals minus 3t plus 3. And that's it. So any questions about this task? Okay, if no questions, let's continue. Yeah, so that's quite easy for you. The task is the next. We need to write down canonical equations of the straight line L passing through the point M0, so with the given coordinates, and it's parallel to different figures. So vector, straight line, coordinate axis, and so on. So how to solve part A? So we have the point and what else we require. So either another point or a direction vector. So any ideas how to solve? Okay, so it seems that you are so shy, but so as this straight line is parallel to vector s, so it means that vector s can be taken as direction vector of this straight line. And then we are writing down the canonical equation. So x minus 2 by 2 equals y by minus 3 and equals z plus 3 by 5. So any questions? So it seems that no questions, but you are so silent. So now the next point. So the next part B. So we need to find the equation of straight line L parallel to this straight line L1. So how to solve it? How to find direction vector? So coordinates of direction vector of the straight line L. So either you don't hear me or you are so shy. Okay, so here,
It's 5, 2, and minus 1.
yeah, 5, 2, minus 1. But by the way, uh, so help your colleague as well. So take part in discussion. Yeah, so as the straight line is parallel, so we can take its direction vector as direction vector over the target straight line. So I will just copy and paste this equation with the changing coordinates of direction vector. Five, 2, minus 1. So part C, it is parallel to axis OX. So what does it mean? So what is the direction vector? So basically for all parts, we need to find the direction vector. Oh, so as the straight line is parallel to axis OX, we can take unit vector I as the direction vector. And the equation will be the following. So 1, 0, 0, and that's it. Analogically to part D, so direction vector will be vector k that corresponds, so the unit vector that corresponds z-axis. Okay, part E. So we need so here we need to find the direction vector of the straight line L. So as it's given with the general equation, so we need to find direction vector in explicit form. So what do we need to do? Please remind me. So how to find the direction vector if we have the general form? Okay, so it can be found as the cross product of normal vectors of these planes. So let's find it. To I plus to j plus 9k plus k plus 6j and minus 6i. So finally minus 4i plus 8j and plus 10k. And for easier, so just to simplify our life related to this, so the part of our life related to this task, we can move 2 out of brackets. So 2 by minus 2, 4, 5. And we will take a direction vector the next. So these coordinates will be coordinates of direction vector. So let's write down the equation of the straight line L. So minus 2, 4, and 5. Then, so the straight line L3. So we know coordinates of a direction vector. So the direction vector of this straight line, our straight line, are the same as for a straight line L3. So who can tell me coordinates of this direction vector? We can see it from the equation. Okay, it seems that no one. Well, so coordinates are the following. So 1, 2 and -1 second. So just coefficients before the parameter t. So let's write down the equation. Any questions about this task? Okay, it seems that no questions. So let's move next. It's quite easy. Short. We need to write down the equation of the straight line passing through 2 points. So the equation is the following. So x minus 1 by 3 minus 1 equals y plus 2 by 1 plus 2 equals z minus 1 by minus 1. And if we reduce it, we will receive the canonical form. So let's simplify it. It's not a lot of work, not a lot of calculations. So x minus 1 by 2, y plus 2 by 3, and z minus 1 by minus 2. So this is the direction vector 2, 3, minus 2. Any questions?
No.
Okay, no questions. So, So basically, it's analogical to the task 5, but a little bit, so maybe not so obvious solution, but analogical. So we need to do the following. So write down the equation of the straight line L if it passes the point K and a point that belongs L1 straight line. So as well, so we need to write down the equation that belong so through 2 points. So how to find the second point? What do we call it? M. So can we easily find it from this equation? Sophia?
It will be -3, 0, and 6.
Yeah, minus 306. So we can take it from here. Yeah, and with this with coordinates of this point, we will write down the equation. So x plus 2 by minus 3 plus 2 equals y minus 5 by minus 5 equals z minus 3 by 6 minus 3. Yeah, we will reduce it to canonical form. Why? Just because we can. -1, yeah, -5, and 3. So coordinates of the direction vector. Any questions about this task? Okay. If no questions, we'll have a break and then continue. So 5 minutes for the rest. Let's continue. So let me share my screen. So task number 7. So we need to find the intersection point M of the plane P and the straight line L. So ideas how to solve it. Well, I will answer this question instead of you. So we need to, basically we need to solve a system of these equations. Well, it can be a question from your side how to solve it because we have so we can say 4 equations and one and 3 variables. Well, here we need to use the parametric form of the straight line equation. So it's time for this. So how to do it? So transfer into parametric form. So everything equals t, not 2, but 1. Or maybe, it can be 1 for me in such not understandable form. So y plus 1 by minus 2 equals t, and z by 6 equals t. So we will find, so we will solve these equations with, so 3 equations with respect to x, y, and z. And then we'll substitute to this equation, to equation of the plane. So, yeah, let me erase it. So x equals t plus 1. Y equals minus 2t minus 1. And z equals 6t. And now let's substitute t, so x, y, and z, so these expressions to equation of the plane. So 2 by t plus 1 plus 3 by minus, okay, minus 2t minus 1 plus 6t minus 1. And now we need to solve this linear equation so with respect to t, and that's all what we need to do here. So minus 6t minus 3 plus 6t minus 1 equals 0. Oh, nice. 6t will be reduced, eliminated. So then what we have? So 2t, so 2 minus 3, so minus 1, so 2t minus 2 equals 0. So t equals 1. And then with the knowing t, we can find x, y, and z. So x equals 2. Yeah, so t equals 1. So x equals 2, y equals minus 2 minus 1, so minus 3, and z equals 6. And the final answer, so coordinates of the point M are the following: 2 minus 3, 6. Any questions about this task?
No questions.
Okay, now let's continue. Then the next task, we need to find the angle between straight lines. But first of all, I will plug in my node, my laptop. Okay, so how to find it? So we just need to find scalar product of direction vectors and divide by the product of the magnitudes. So let's do it. Yeah, of course, let's better write down coordinates of direction vectors. So 1 minus 4, 1 for the first uh, straight line, and for the second, 2 minus 2 minus 1. So, uh, so finding first of all cosine of the angle, and then we will check if it's uh, if it can be found from the tables. Okay, 1 plus 16 plus 1 by 4 plus 4 plus 1. So here we have 18 by 9. So let we leave it for now in this form. So 2 so 2 minus 8 is minus 6. So stop. Yeah, minus 6 minus 1, so minus 7. Oh no, 1, so 8, 1 plus 8 plus minus 1, so 9. So what we're having here, so we can move 9 out of brackets. So 9 by square root of 2. Yeah, and we have 1 by square root of 2. So phi equals uh, p by 4. So yeah, this is a value from p by 4, by the way. So it's a mistake here. Well, so any questions about this task? No questions. Okay, and now let's find. So let's verify that two straight lines are perpendicular. So we need to find the scalar product of direction vector. So for the first coordinates of the first direction vector of the first straight line are the following. So 2 minus 1, 0. And for the second straight line, 1, 2, 4. So calculating the scalar product. So 2 minus little mistake. So 2 minus 1, so minus 2 plus 0, so yeah, 0. So, and the final answer, so that L1 is perpendicular to L2. So you always have to write the conclusion, the final answer. Any questions about this task? Okay, it seems that no questions. And as well, so that was required to verify, so the final answer. And now let's move to the task 10, the final task for today. So we need to find the projection of point M on straight line L. So first of all, let's draw a little bit. Uh, mhm. So, this is the point M, and so if we draw so imaginary perpendicular, so this is the so N will be the projection of the point M. And how basically to find it? So we need to write down so we need to find, first of all, the plane that is perpendicular to this straight line, and that contains point M. So basically, what do we require for it? We need point M and coordinates of normal vector. So normal vector is the following. So it matches the uh, direction vector of the straight line L. So we will find the plane, and then we will find the intersection point of the plane and the straight line. So 2 by x minus, no, just 2x minus y minus 1 plus 2, no, plus z minus 2. Yeah, so confusing coordinates a little bit. And now let's expand brackets and write the general. So 2x minus y plus z, so 1 minus 2, so minus 1 equals 0. And now we need to find the solution of this equation. We need to find the intersection point with the solving system of equations of the straight line and the plane. So as we did before. Okay. And let's rewrite in parametric form the canonical equation of the straight line. So, okay, this will be without changes. Let me maximize the window. So x equals 2t plus 1.5. Y equals minus t. Z equals t plus 2. And now let's substitute into the equation of the plane. So 2 by 2t plus 1.5 plus t plus t plus 2 minus 1 equals 0. So what we have, so 4t plus 3 plus 2t plus 1 equals 0. And finally, so 60 equals minus 4. So t equals minus 2/3. Now let me check if everything solved correctly. Yes, so minus 2 by 3. So coordinates of the point N are the following. Yeah, so x equals okay, minus okay, minus 4 third plus. Okay, what we not waste time for calculate fractions. So we will just believe my calculations here. So coordinates of the, okay, here is k, but we named n, but it doesn't matter. So coordinates of this point are the following. So 1 by 6, 2 by 3, and 4 by 3. So we found, so we solved task A, part A, we found the projection of the point M. And now we need to find the coordinates of the point M, point M prime that is symmetric to the point M relative to this straight line L. So how to solve it? Any ideas? Which formulas can we use? Spoiler was. So no ideas, yeah? So what can we say about these distances? Mn, and so distance between m and n and n m prime. Are they equal? Yeah, let me duplicate. So are they equal or not? How do you think? So yeah,
No.
sorry?
And I think they are not equal, but I don't know.
So symmetric to so this they are equal, so because m is symmetric, m prime is symmetric to m, and vice versa, of course, relative to this straight line. So distance so their distances between distance between m and straight line is equal to m prime and straight line. So n is the middle point of the segment m and m prime. And how to find the middle point? Coordinates. What do you remember from the vector algebra? Which formulas to use? Okay, I will remind you. So we need to add coordinates and divide by 2. But we know coordinates of n, we need to find coordinates of m prime. So xm prime equals 2xn minus xm. So 2/3. Okay. Let me copy and paste our coordinates. So M and N. So 2/3, and that's it. So ym prime, so analogically, it equals 2yn minus ym. So 4/3 minus 1, so 1/3. And zm prime equals 2zn minus zm. So 8/3 minus 2, so 2/3. So, and the final answer, coordinates of the point M prime are the following: 2/3, 1/3, and 2/3. Any questions about this task? And let's check. Yeah, so 1/3, 1. Okay, let me double check it. Yeah, so here is 1/6, and that just was a mistake. So let's correct it. So it was the final task for today. Any questions, comments about this task, previous tasks, previous lessons, other questions?
У мене є питання. Нам видали вже ІДЗ номер 2, а до коли його потрібно здати?
So is there a deadline on DL? So let me...
Немає.
Okay, I will ask Svetlana Mykolaievna about this. But anyway, so yeah, you have time. Anyway, you have some time for it because we have at least one more practical lesson for this module. Oh no, for your group, even 2 practical lessons. So you have time for that, but of course, don't не затягуйте. So don't put it off. But yeah,
Добре,
I
дякую.
will ask about this. More questions?
Дякую.
Okay, if no questions, so now we are finishing. Today we finished quite fast. So have a nice day. Stay safe. Thank you for your attention. Recording will be available on YouTube. Goodbye.
Thank you for the lesson. Goodbye. Have a nice day.
Bye.
Goodbye.
Thank you. Goodbye.